Howdy students, this is the answer key to the all shook up varied mole problems. We're going to do problems 1 through 5 in this video. So let's start with the conversion factors at the top right of the page. 1 mole equals 22.4 liters of space at the standard temperature and pressure. And remember, the standard temperature is 0 degrees Celsius, which is the freezing point of water, and the standard pressure is 1 atmosphere, which is at sea level. 1 mole equals, we're going to call it the GFM, gram formula mass, what we usually call molar mass. So remember, you have to calculate this conversion factor depending on the chemical compound you have from the periodic table of elements. 1 mole equals Avogadro's number, 6.02 times 10 to the 23rd power. And remember, particles can be atoms, ions, which we really haven't seen quite yet, formula units, and molecules, which we can abbreviate MC. So let's go ahead and move on to question 1. So we're going to calculate the mass of 4.0 times 10 to the 4th molecules of water. First step here is going to be starting with what I am given, times 10 to the 4th molecules. I'm going to abbreviate MC of H2O, that's water. I'm looking for mass. So this is going to be a 2-step problem. First step is going to be using Avogadro's number, 6.02 times 10 to the 23rd molecules of H2O, and that's going to be 1 mole of H2O. Step 1, now I'm going to have to use molar mass. For every 1 mole of H2O, I have 18.0 grams of H2O. After I calculate, final answer is 1.20 times 10 to the negative 18th grams of H2O. Next problem, how many grams are in 5.7 moles of potassium permanganate, which is KMnO4? So we're going to start with what I'm given, 5.7 moles of KMnO4. So this is going to be a 1-step problem. 1 mole of KMnO4. I'm going to go ahead and provide you with the molar mass of KMnO4, and that is going to be 158.0 grams of KMnO4. And I'm going to stop there and calculate. My final answer is 9.0 times 10 to the 2nd grams of KMnO4. Number 3, how many grams are in 3.45 times 10 to the negative 4th formula units of FeO, which we call iron oxide? In this case, it's actually iron 2 oxide, which we'll learn about in Unit 6. 3.45 times 10 to the negative 4th formula units, which is a particle. So we will be using Avogadro's number here. I'm going to use 6.02 times 10 to the 23rd formula units for every 1 mole. And our compound, I forgot to write it up here, was iron oxide. I was a little lazy. 1 mole of iron oxide. And I'm looking for grams, so I'm going to have to go one more step. For every 1 mole of iron oxide, I need the molar mass. So again, I'm going to provide that to you. Otherwise, you would have to calculate 71.8 grams of iron oxide from the periodic table of elements. Final answer there is going to give us 4.11 times 10 to the negative 26th grams of iron oxide. Next one. How many moles are in 69.3 grams of aluminum iodide, ALI3? 69.3 grams of ALI3. I'm looking for moles. This is going to be a 1-step problem using molar mass. The molar mass of this compound is 407.7 grams of ALI3 for every 1 mole of Al(I3). That is a large molar mass. Iodine itself has a molar mass of 126.9, so 3 of those makes it a very large compound. And we're going to go ahead and stop there and calculate. Final answer here is 0.170 moles of Al(I3). Some of you may want to turn it into scientific notation, 1.70 times 10 to the -1. Either answer would be acceptable there. And last one for this video, this is number 5. How many propane molecules are in 25.00 grams of propane? So 25.00 grams of C3H8. This is going to be a 2-step problem. I have to go mass into moles, and then I'm going to have to go moles into molecules. So, sorry about that. My pen was not allowing me to write on the screen. So if you need to go back and look at 1 through 4, go back in the video. I'm going to go ahead and start question 5 here at this point in the video. So once again, we have 25.00 grams of propane, which is C3H8. 2-step problem, because we got to go grams to moles and then moles to molecules. So the molar mass of propane is 44.0 grams of C3H8 for 1 mole of C3H8. And then I'm going to use my molar conversion, Avogadro's number, and say that for every 1 mole of C3H8, I have 6.02 times 10 to the 23rd molecules of propane, C3H8. And when I calculate number 5, I'm going to get an answer, 3.42 times 10 to the 23rd molecules, MC, of C3H8. Okay, check out the next video for questions 6 through 10.